Hello, everyone, and thank you for joining. Welcome to my session about fantastic packers in malware and where to find them. So this session will be kind of a hybrid session. Some part of it will be an actual lecture, and some part of it will be hands-on training. A couple of words about myself. My name is Eli. I'm lead threat hunter in Cyberism. I'm in the cybersecurity industry for several years now. Started as a security analyst, threat hunter, and now I'm leading a threat hunting team. In recent years, I published several researches, mainly on cybercrime and malware research. I also have a computer science degree and several reverse engineering certifications. So what will be the agenda of this session? So first we will present what is a packer, why malware want to use it. We will also discuss what is a custom packer and how we identify custom packers. I will also present several case studies of the last decade, and I will also discuss about what an additional information we can get from it. So to get things straight, what is a packer? So basically a packer is a software that compress or shrink an executable or a payload. So it's doing it in order to obfuscate the content of this real executable, hide the real data or code, um, avoid detection by antivirus companies, and slow down researchers or malware analysts that trying to investigate this file. So how packers work? So most of the packers are working a similar way. They take as an input an executable or the payload, and in return, the output will be the new packed executable, which will have a new headers and a new section. Um, the packer also changed the entry point of this executable to its own entry point of the executable. And obviously during runtime, the packer is also responsible for resolving the dependencies and also to change the entry point and return it to the original entry point of the executable it packed. This is just an image for demonstration. We can see the malware payload or the original executable, and after the packer work, it's being packed uh, by the packer. So there are several different type of kinds of packers. Some of them are free or open source, such as RAR or UPX. Some of them are commercial packers that are used to conceal and protect licensing system of product, such as Temida or VM Protect. Some of them also have anti-analysis capabilities as VM Protect. And there are custom packers, which are the packers that are been crafted or been written by the attacker. And that really leads us to the main topic of this session. So what is a custom packer? So a custom packer, also known as a scripter, is basically packers that have been written by the threat actors, by the attackers. So basically, in other words, every unpacking or decrypting mechanism or decrypting executable that's been written by an attacker to hide an actual payload. Um, so really, the question is why attackers want to waste their time to create their own packer, which is actually a product. It's a code, basically, if there are already an open source alternatives. So first of all, it gives them better control because as a programmers, if they wrote the code, they know really how the code works, and it gives them really the best understanding about the unpacking mechanism. And if they do have a great understanding of this mechanism, and if they wrote the code, they can improve that. So for example, they can create a packer, upload it to sites such as VirusTotal, see what are the detection rate, and then tweak it and see again what are the detection rate. And obviously they can add whatever they want, and some of it are anti-analysis capabilities. So really, if the attackers improving their so-called product, how we as a defenders can catch up. So the majority of these custom packers or cryptors actually uh, share a lot of similarities or concept in them. And if we as defenders will understand those concepts and will anticipate them, we can actually overcome most of these new packers, at least just by understanding what needs to happen so we can search for it, for example. So the first case study that I will present is the get2 downloader. So this malware was first emerged in 2019 and associated with TA505 threat actors. It's been known to deliver several malware, but the most notably, obviously in recent year, is the STB bot. So for this first case study, I will present it dynamically just to show an actual hands-on uh, Packer unpacking mechanism and what are the concepts we would like to search for. So I will go to my virtual machine and I will put the get to downloader binary into my debugger. Awesome. Now, the first thing that this malware do is to allocate a new memory, as actually a lot of malware do. So because I know it, I will search for allocations of new memory. So in order to do that, I will write set bpx virtual alloc. Awesome. Now I have a breakpoint on every newly allocated memory that will be allocated by the malware, and I will just track it. Now, because I know this malware, I know that this malware, this version at least, allocate 3 times, but I will only focus on the last 2 times. So I will hit run. One time a virtual alloc has been hit. I will click again. Second time, I will run to the user code and will observe the newly allocated memory, which is stored in the register EAX. Now, just to track it in the most efficient way, I will just set a breakpoint on every time that this newly allocated memory will be filled or something will write stuff into it. So to do it, I will right click, breakpoint, hardware write, and I will tell him when a byte is been written, tell me about it. Awesome. I will click run again, and as I said, another third virtual alloc. I will go to the user mode, and I will also inspect using the register EAX the newly allocated memory. I will similarly, I will set a breakpoint on write, and great. Now, just pay attention, the dump 1 is the first allocated memory, and the dump 2 is the second. So I will observe the dump 1, and I will hit run because I already has a breakpoint on these 2 allocated memories. So every time something will be written, I will be know about it. So as you can see, I click run, and something has been written. Now, we can see that after this activity of writing the byte happens, we can see a jump. Now, let's watch closely on this ASCII table. and we can just see, let's take this jump, and let's go again. And for those who will be looking here, we will observe that when we were here in this part, some data was written inside this newly allocated memory. So, and this really leads us to the first two concepts that I want to present here. First, usually when data has been poured, whether it's from the binary or being deobfuscated, uh, attackers like to modify or write their data or read from that data byte by byte. So in this case, we can see that some data has been entered to the register CL, which is a 1 byte register. And this register is being moved, you can see byte, 1 byte, to the EDX, to this address that here. So the first concept that I want for us to understand is that we want to look for byte by byte activities, something data that is being written byte by byte. Now, in order for that data to be written byte by byte, it has to be happens inside a loop, because it has to be written byte by byte, and to do it, it has to be inside the loop. So, and this leads me to the second concept that I want to show here. Whenever it's unpacking, decrypting, deobfuscating activity, we will always want to search for loops, because if we need to write data, whether it's byte by byte or 4 bytes, 4 bytes, it must be happened inside the loop. So this is the second concept. And I would just set a breakpoint here, because I know that this line will write the byte here, and this line obviously take me to the loop. So if I will click run, we can see that I came to the address that writes the byte. And if you will look here, you can see that once I will pass it, another byte was written. Let's do it again. Breakpoint, you can see 0, 0. I will click step over, and we can see 51 here, or some changing here. Now, awesome. So I know that this loop is actually pouring some content inside this newly allocated memory. So after I understood it, I will just set a breakpoint right after this loop. So I will see whatever is being written. I will click run, and we could actually see that a lot of gibberish content has been written inside this newly allocated memory. Great. But for those of you who are searching for portable executable, obviously this is not what it looks like. It looks like a gibberish. We would want to expect the classic MZ header. So let's continue our debugging activity. So once we will continue, we found ourselves encountering another loop that started from this jump and returned to here. But if you will look closely to this first allocated memory, we can see that the bytes has been changed. We see now M8Z. Now, we obviously can assume that this is start to be more similar to what we want to look for, the classic MZ of the portable executable, the classic portable executable starting. So we can understand that this loop maybe alters some of the data here. And this leads us to the third concept that I want to present. We can see that this loop contains of several of what I call data manipulation opcodes. and in this case, we can see shift right, we can see the XOR, and we can see the rotate left. Now, these specific opcodes are known to be used in actually the majority of cryptos or decryption algorithms that I have observed in dynamic running. So their presence inside of loop is always a good indication of maybe some decrypting or the obfuscating activity. So just see, let's continue to iterate about this loop in this loop again, and we reach the end of this loop. Now we understand that let's for example iterate this loop again, but now I will just set here a breakpoint. We could see that something has been changed. I will press again, and if you will look at these lines, we can see that the data has been changed. Awesome. So we understand that that this loop actually modifying the already written content, the already obfuscated content. So awesome. I will just set a breakpoint right after this loop, and I will hit run, and obviously a lot of stuff will change here. Awesome. So now, except the MZ, we can actually see that something that will look like this program. So DOS ODE. So this is kind of telling us that maybe this starts to resemble us. This program cannot run in DOS mode as we expect in a portable executable. Great. So because I still have a breakpoint, the hardware breakpoint on these two, I will click right again, and let's see what happens. Great, so now I reached this point, but I look on the second allocated memory, and I can see the letter M. So I understand that some data is starting to be poured into this newly allocated memory. So let's just do step over a bunch of times, and let's see what's happened. Okay. Something happened. Now I see the letter Z, MZ. Now this is really starting to look like the portable executable we want to find. So I believe it was this place that copies. So again, we observed that some content has been written. I will click again. We can see here 00. Click again, and we can see that after I pass this line, this red line, this move of 1 byte, the 00 turned to be 90. So again, moves of 1 byte. And these moves happened again inside of a loop. So this is great. So I kind of understand that maybe this loop will give me some deobfuscated data. I will write run again just to see it again. Great. I can see that I said that the bytes will be moved byte by byte to this EDX register from the CX register, but it's coming to the CX from the EAX. And if I will inspect what this EAX is, and I wrote on jump 3, I will see that this place is actually the first allocated memory. You can see this is the same. So I can assume that some data in some pattern is being copied from here to here. And because this is here, it's M3, M8Z, and here it's MZ, I can assume that it may be copying the exact bytes to give us an actual portable executable. So let's confirm my hypothesis. And obviously, this is the loop that's doing everything. I will just set a breakpoint after the loop and click run. And what you see, we can see an actual portable executable here. Uh, MZ, this program cannot run in DOS mode. Um, yeah, so this is the unpacked. Now, this is not really fully unpacked because we can see here UPX0, UPX1. So this is actually unpacked, but still packed with the UPX packer, which is something that attackers like to do to just for good measure to unpack it, to pack it with double packers. Great. So after we understand these concepts, I will I will continue. Um, I will continue to the second case study, which is Stuxnet. Now, Stuxnet is a malicious worm, computer worm that discovered in 2010. It's very famous, and its target the programmable logic controllers, or PLC, which basically control the centrifuges in Natanz enrichment facility in Iran. Um, now, if we, I will just move it here. Now, if we observe, now I obviously dig in the code of Stuxnet, of the first initial dropper of Stuxnet, and I observe this function, which is the function that is responsible for decrypting the dropper. So when we observe this function, we can actually see the same similarities that we just observed in the get2 malware. First of all, it has a loop. It actually has 3 loops within a bigger loop. So 4 loops. The second concept is data manipulation opcodes. In this case, we can see XOR and shift right. The third concept is moves of 1 byte. We can see it down here. So awesome. So let's see how this unpacking mechanism really works dynamically. Here I will not actually run it, but I will just present it in the slides. So we talked about 3 loops inside a bigger loop. So we can see here that the first loop starts at the beginning of this gibberish content, and it really iterates down. It's doing some XORing activities, and we can see that it finished down here. The second loop is starting from the beginning of the content, but it also stopped at the middle of this obfuscated data. And the third loop, which is actually very interesting, starting from the bottom of the obfuscated data and goes up to the beginning of this obfuscated data. And we can see the reason for that is it's because we can see this -1 here that just take it, and the sub here that just take it, the decryption mechanism, instead of the classic from up to down, is taken from down to up. And all of these loops are in one bigger loop. So after we set a breakpoint after this loop, we can see the clean portable executable MZ. This file cannot run in DOS mode, and actually similar to the get2 downloader, the Stuxnet malware was also packed with UPX malware, so double packers here and there. The third case study that I want to present is actually very new. It's about the teardrop malware. Now, this malware is related to the supply chain attack on SolarWinds Orion platform that was discovered in December 2020. Actually, the name teardrop was given by FireEye. And yeah, the main goal of this malware was to deliver a Cobalt Strike implant. So if we will look on this decrypting function of the teardrop malware, we can see actually first of all, obviously it's a 64-byte malware. We can see it because of the registers RCX and so on. But we can see that it has actually shared a lot of the similarities that we already seen. First of all, it has a loop here. Second, it has the data manipulation opcodes. It has shift right, shift left, and XOR. And at the end, there are moves of bytes at the end of the loop. So yeah, it's kind of interesting because it's been a decade since from Stuxnet to Teardrop, but the concepts are actually the same. So what an additional information we can get from the custom packers. So here I just gave some picture, an image of and actually 3 droppers of malware. Now, if you will look on these 3 images, you will tell, hey, it looks the same, and obviously it's basically looks the same, the same opcodes, the same everything. Uh, but when I investigate these 3 malware, the fact was that although the custom packer was the same, the payload was not the same. One of them delivered the ORSNIF banking Trojan, one delivered the Quackbot banking Trojan and loader, and another one deliver the Emotet threat loader / botnet. So what an additional information that what an additional information we can learn from these custom packers. So just from inspecting these custom packers, we can assume or maybe understand that packers actually can be a really good indicator of compromise, or at least narrow down the options significantly. Because if a packer is known to be used just for one malware, so maybe it's a strong enough IOC to indicate about this malware, or at least about several malware that use this packer. Now, the use of this packer or the use of them in a malware can maybe tell us about some collaboration between different threat actors. Uh, so if, let's say, the threat actors that related to Emotet and Quackbot and Ursnif use the same custom packer, maybe that can let us understand that maybe there are some collaboration between them, or maybe some third-party actor write these packers, and the other threat actors buy that from it. Now that really leaves a lot of room to think about these subjects. So let's talk about conclusions. So in this presentation, I present and talk about decryption and the obfuscation mechanisms. We actually see that although a decade or a lot of time actually passed from Stuxnet to get to or Teardrop, most of them just share the same concept or similarities. So something for conclusion and for enrichment. So traditionally, packers tend to start with reading and obfuscated data from the PE itself, the embedded PE, embedded from the PE, and writing it to a newly allocated memory. Writing to or reading from in a lot of cases will happen byte by byte. So we should look for byte by byte activities, mainly writing activities. Also, in order to do it byte by byte, that has to be in the context of a loop. So we want to look for obviously loops, but loops that contain this activity. And also some opcodes that manipulate data, change the data, can be seen in most of these custom packers, most notably XOR, rotate left, rotate right, shift left, shift right will most likely, or there is a high chance that we will see them in a decryption loop. So first of all, thank you all very much for your time and for listening. And if there are any question, I will be happy to answer.